So today I'm going to go through how to differentiate x times cos of x 12 times. We're going to use the Leibniz rules, which is that the same as the biscuits? I don't know, but I think that's how you say it. You can also do this by using the product rule, I think multiple times, then you find the pattern, but we're going to be using this technique. So I'll teach you what to do. I'll explain all the steps. I have written out my work in prior, but I think that's just so I can make sure, I haven't made mistakes, and I have gone through it a couple times, made sure everything's correct. I've explained the result of differentiating sine of x, cos of x, and so on and so forth. I'll go into that in a second or a bit later because that will be relevant. And yeah, we're just going to apply the Leibniz rule to our question. And then from there, we can kind of just simplify it and then we get our final answer. So it's quite nice and easy. So let's start by looking at the Leibniz rule. I really hope I'm saying this right because I've been saying it a lot. So the Leibniz rule, d over dx, both to the power of n. So basically how many times you're going to differentiate something. That's all it means. In this case, ours is a 12 in each spot because we're differentiating 12 times. The u and the v are two, I guess, functions, or I mean, you could call them terms, I guess, but I don't know. But let's just call them functions. So we'll make x our u and cos of x our v. So, and you can kind of choose how you separate that out. In this case, it's quite easy because there's just two distinct terms. But yeah, you could technically do it anyway if you have multiple terms. Anyway, I'm digressing. And that is equal to the sum of 0 to n, where n's our final number, which is 12. And you basically do this however many times you have for n. So when it has that sum all, let's say this was 0 to 3, you would try it where you, for example, have 0, 3, 1, 3, and then you do it 3, I think it would come up 4 times because you start with the 0. And you basically do it for all the values. That's what this means. You have the separate terms. This is a binomial coefficient, I think it's called. I'll explain actually, what that's equal to. It's I don't have it up at the moment. I'll show you what that is equal to. It's something you have n factorial over n minus r factorial, but I'll pop that up now actually so you can see it. And then here we have, I guess, more of the actual function, or the significant part of it. And you have d to the power of n minus k, so it'd be 12 minus whatever number times u. U is our, we assign that to x. And then it's over dx to n minus k, so same power as that one. Depending on how far you've gone along, it'd be 12 minus whatever k value you're on. And then this one is d to the power of k, so that will increase as k increases, times v, which is cos of x, over dx k. But it's really d to differentiating with respect to x, k times. Yeah, so I hope that makes some sense. It might make more sense once we start writing it out. This, we probably don't need to go into this yet. So let's start expanding. So you could also do this back to front as well, I think, a little bit with the, but I don't want to overcomplicate everything. But so we're starting with d12 over dx 12 of x times cos of x, which is our original question. And that is going to be equal to, so for example, this first term, we're going from 0 to 12. So we start with the 0, we put 0, 12 here, just like how we have 1, 12 on the second term and 12, 12 on the last term. For our first term, the n value, or the n value will stay the same, won't it? Because that's our maximum, I guess, value in the differentiation sense, how many times you're differentiating. So you have 12 minus k, so it'd be minus 0 because that's k for our first step, and that's n. So d to the power of 12 minus 0 over dx to the power of 12 minus 0 times u, which is we've assigned to x. And then that is times d over dx, k times, which is 0. So I mean, I will double check this before I upload the video, but because it's like to the power of 0, pretty sure that means like you're not differentiating it. It's like, so that will just stay as cos of x. But anyway, so you do that for each of the terms, making sure you change the appropriate k value, and that will affect the powers here and here. I think that m value should stay the same, shouldn't it? Because that would just be 12. Anyway, so with these things as well, especially when you have like infinite ones, you're not going to write them all out. This isn't infinite, obviously. But I did the first, what did I do? The first couple, and I did the last 3. I did the last 3 because I wanted you guys to see the last 3. Now, the first, like, what's that, like 10 or 11 or whatever, or however many, they just disappear. I guess there's probably 13 terms, right? Anyway, it doesn't really matter. But the ones with d over dx against the x, where it's anything more than once, really, because if you differentiate x once, you get 1, and if you differentiate it again, you'll just get nothing. So I'll just repeat that. Yeah, if you differentiate x, you get 1, and if you differentiate 1, you get nothing. So like normal differentiation, right? If you do it twice, it would just disappear, which means all these terms at the start are kind of pointless. They're going to like disappear. That's why I left the last 3 in, because so it's lowering down d over dx twice. That will still disappear, but these last 2 are actually going to be of some use because they're going to stay. So we really just need to focus on those 2. We could cross them out if we wanted. I'm not going to because I might have to redo the video. But yeah, hopefully that makes sense. So let's focus on these last 2 terms. So I'm going to explain now what these are, so how you can work these out. I'll pop that up on the screen. It's basically just, like I said, it's like n minus r or n over n minus r factorial. Like, it's not that hard. Factorial is kind of like it's with the exclamation mark, and you do like 12 times 11 times 10, and it counts down, I think, to 1. And then you don't have to like times it all out, because imagine if you had like the 12 and the 11, right? If you had 12 factorial, it'd be 12 times 11 times 10, and if you had 11 factorial, it'd be like 11 times 10. If you divided them by one another, the 11 factorial would cancel out almost from the 12 one, so you'd just be left with 12. But you can work that out for yourself, especially at this level. It won't be very hard. So that one, I believe, becomes a 12, and the first number here, that becomes a 1, because they kind of cancel each other out. And I will double check this, but I believe 0 factorial is 1. I don't know why, I haven't taught myself that, but there's a thing, in case you didn't know, in case you get stuck. God, what am I doing? Okay, so I feel like I'm rambling on, but hopefully this makes sense. So for the d over dx, this is just 1, so that becomes 1. And this is not differentiated at all, so that stays as x, okay? And we have the 1 from the 12, 12. So that explains the 1 and the x and 12 and 1. Now, where have we gotten these from? So for the other part of these last 2 terms, we have cos of x being differentiated 11 times and cos of x being differentiated 12 times, which sounds really annoying and really long, but it's actually quite easy to work out, and that's where this comes in. So I remember that, I want to say I came up with drawing it like that in secondary school, no, at A level, but I'm sure someone else has drawn it like that before. But it's cyclical. So if you differentiate sine of x, it's cos of x. And let's say we wanted to differentiate like 5 times. You'd be like, okay, we start here, 1, 2, 3, 4, 5. You just keep going forever, right? And because there's 4 of them, and for example, with the last one, we're differentiating 12 times. So let's say you have cos of x. Let's do 4 first. So we're at cos of x. We go 1, 2, 3, 4. 1, 2, 3, 4. Yeah, it's sets of 4. You're differentiating it 12 times. So 16, 20. It's still going to be cos of x, if that makes sense. And for the 11th times, you'd just do 1 less. So 1, 2, 3, 4, 1, 2, 3, 4, and you'd fall short by 1. So we're not integrating, we're not going back up, we're just differentiating 1 less time. So that leaves us with sine of x for that one. And yeah, hopefully that makes sense. I feel like that's not too bad. I cleaned it up a little bit. I don't know whether you should write cos before sine in your final answer. You can do. X cos of x times plus 12 sine of x. But yeah. Hopefully that made sense. Hopefully it was clear. I feel like I've said I don't know a lot, but I'm pretty sure it's right. You can double check it with someone. If you do have comments or questions, I can try and help as much as I can. In terms of like requests and stuff, I do work full time, so I'm quite busy. But it's been fun trying to get back into the maths and doing a bit of a higher level, like something a bit more challenging. No offense, you people doing GCSEs. But yeah, I'm happy with all of this. Let me know if you're not, if you have any comments or questions. Obviously, if there's a mistake, let me know. But I've checked it quite a few times. It should be good. Checked it online. So yeah, let me know if you have comments and questions. I'll do my best to get back to you. Best of luck with all your maths, and thanks for watching.